Hello, humanoids. Welcome to episode 9 in our course on ethics and science. It's Akbar and Adam coming at you. Today, we're going to talk about values in science, following on last time, talking about what is science. In a way, this whole course is about values in science, so we will just try to hit some of the highlights today. And as we jump into it, you will see that really, in addition to some general remarks about values in science, the purpose of this lecture is to walk you through the assigned reading, Merton's The Normative Structure of Science. The more I teach this class, the more I see this essay as central and foundational for the class. So I want to make sure you understand it. So I think I will take a little time to walk through it with you. I'll first have some general remarks, then we'll go through the context of that essay very briefly. We'll walk through its most important points, especially the fact that norms in science derive from its goal. I want to make sure you get that. And then he's got these 4 norms or rules of science that are about these values built into it. So that's what I want to do. First, though, our series in Akbar reads the news. I just am getting, like I say, I guess I just everywhere I turn, it's this course, like everything I see. So UNT, for example, recently sent out this note about how researchers here are working on solar cells that could be flexible, that is funded by the Navy. So you can go and check that out. I put links to all of this in your notes if you're curious about this stuff. And as they say here, this is wonderful because we need to transition to renewable energy. Of course, it's military funded science, which raises interesting pros and cons from an ethical perspective as well. And then something I'll try to come back to with Merton. Look at this story from the New York Times. You know, we're in this race to find a vaccine, and it's become totally nationalized. And you got the US and China and Russia and others like pitting themselves against each other. And now you've got evidence that there's spy networks going on trying to find out what each other knows about the science. And Merton would say, this is crazy because science needs to be a universal enterprise and should not be infected with these nationalistic dynamics. I don't know what you think about that, but that's something for you to consider. Okay, I just want to emphasize again, those of you who enjoy science, but you don't see yourself maybe becoming a scientist, there is a whole community, very diverse, with a long history of people who study science as it takes place in society. They study the social and ethical and legal, historical dimensions of science. And these are just a few books here that I'm drawing from for this lecture and for this whole course. And it's the community I find most interesting. I think science is super important and fascinating, but I'm not a scientist. But I try to think scientifically about science, and that's kind of what we're trying to do in this class. Okay. I thought I'd give you just briefly a concrete thing to keep in mind. And you may or may not have heard of it, but this new genetic engineering technology called gene drive. I just got an email from Texas A&M University asking me to take a survey on gene drive technology. And basically, it just means you could take a pest species, whether it's an insect or a plant, and insert a gene into it that would have the effect of spreading throughout the whole population. And if you inserted a gene, say that everybody who has this would become a male, you could drive that population to zero or close to zero because there would be no females left, right? So this is what they're talking about. This is a way to eliminate pest species. And the questions, I just put them up here. You can look through them. I try to remember what they asked. They asked some really good questions about this technology. At the end of the day, do you support it or not? Do you think it needs to be reversible? What if other organisms are impacted? What if you want to release it in the US, but it goes across to Canada? What if it causes a species to go extinct, a certain mosquito species, right? Is that something good or bad to do? Should we only use this as last resort if pesticides aren't working, say, or other pest management techniques? What should the regulations look like? who should have a say in developing those regulations. This is all ethics and science, right? So this is just another case study you can keep in mind if you want for these general points. Values. I started looking, I got a little bit down a rabbit hole. What do we mean by values? I don't think philosophers actually have given a good definition of it. We kind of just lean on your intuitive sense that you're talking about values when you use language like good, better, and best, or right and wrong, or beautiful and ugly. And there's this whole field of philosophy called axiology, which studies values. But you can think about values whenever you're evaluating something, good, better, best. You're talking about values. There are lots of values in science. Some of them we talked about already are epistemic or about knowledge, the rules you have to follow in a non-narrative form of rationality to arrive at legitimate or validated knowledge claims, right? There's also ethical values in science. That's what we're doing today, mostly. Before we get to Merton, keep in mind these meta questions and meta values, just like values about values or questions about questions. I think the most important meta question is, okay, so there's values in science. When do values play an appropriate or an inappropriate role in science? For example, be honest. Okay, that seems like an appropriate value. In fact, a necessary value for science. Don't substitute your personal or political wishes for the facts. So if certain values like, oh, I really want to prove that my experiment works and it turns out the evidence shows it doesn't work, but you really want it to work, so you just sort of fudge the data. Well, that seems like an inappropriate, right, place for values or thing for values to do in science. So our task isn't just to say, oh, there's values in science. Well, which ones? Where should they be there, right? This is kind of meta valuation, thinking about what values are appropriate in science. From Kevin Elliott, one of the books I showed you, he does a nice job of saying there's these kind of meta values. So to get at that question of, well, when are they appropriate or not? Well, we need to, first of all, as scientists say, be transparent about the values-based decisions that are in the research we're doing so that we're open about it. So that then we can ask whether the values that are built into it are representative of broadly held values in our society. And also, only if we're transparent can we open the door to participation. And in that gene drive survey, it was really interesting that they would ask me, I mean, I'm not particularly involved, but yet I do eat food, right? So I have a stake in the agricultural sector. So who should be involved? And maybe it's a good thing to get more and more people involved, or maybe not, right? So those are sort of meta questions and meta values. Again, last thing before we get to Merton, this is from, adapted from Kevin Elliott's book that I showed you about a tapestry of values. I thought this was just useful. If you're still thinking, what do we mean by values? Well, think about this. What should we study? For example, gene drive. Should we even be studying that? Is it too dangerous to even look into? How should we study it? Talked a bit about the methods that we might use. What are we trying to accomplish and whose interests are being served by this? Is this going to be another thing with gene drive that serves the interests of big ag, say, whatever we mean by that, in a way that hurts small farmers? Or will it actually be good for small farmers? Whose interests should we be serving? Right? How do we handle uncertainties? And how do we communicate our research findings? We talked a bit about the media and the importance of thinking critically about the way science gets mediated. A big one with gene drive and a lot of science. What about possible unintended consequences? How many of those should we foresee? How do we weight the possibility of them happening versus foreseen beneficial outcomes? And then how do we distribute recognition for the good things that happen in science? Who should get credit, right? And what about the bad things that might happen? How do we distribute responsibility and blame for those? So these are just to get you thinking a little more concretely about all the ways in which ethical questions and values are necessarily woven throughout science, right? Now, a bit on Merton. Why this guy? Well, I don't know if anybody's in sociology, but he's one of the founding figures. He developed key terms like unintended consequences, self-fulfilling prophecy, the role model. He didn't invent these terms, but he made them into really robust sociological terms. He's also a founding figure so important for us in the sociology of science. Again, this is a whole field now that if you're interested in, you can study. He was interested in what is the place, what's the appropriate role of science in society, and he did a lot of pioneering work there. And the essay I had you read I think is, well, in my opinion, the most important one. So he's talking about the ethos of science. What are the values? Ethos is like ethics, right? The ethical values that hold science together. And how can science as its structures deviate from that in dangerous ways? That was his question. And if you think about the context, 1942, we're in World War II. We have the rise of Nazi Germany and Soviet Russia. And in both of those non-democratic regimes, you had these mortal threats being posed to science. This is what Merton was seeing. I just put a couple of things. Again, these are linked in your notes. Well, the Lysenkoism is just the Wikipedia. I'm not sure I linked that, but you can look that up. In Nazi Germany, for example, you have Aryan physics and a claim about Jewish physics and how Aryan physics is superior to Jewish physics. That's something deeply wrong, right? That Merton was trying to analyze. So this is why he's starting to think and write this essay. Soviet Russia, you have geneticists being jailed because they don't have the right theory. And you have this guy Lysenko who has a questionable theory, but Stalin favored it. So you have political influence being substituted for scientific judgment. And this is incredibly dangerous, he said. So this isn't a story about those case studies, right? But this, I just want to give you a sense of, Merton was writing this because he saw existential threats to science going on around the world. And so he wanted to articulate and defend the normative structure of science that he felt was being under attack in both Nazi Germany and Soviet Russia. Something had become corrupted here. Okay, so let me walk it through in just a couple slides. First, science is separate from society in some important ways and needs to be. You can't have Stalin telling you what the appropriate agricultural theory is or how plants work, right? Those are the scientific questions. Nonetheless, those scientists are dependent on certain social structures. So they have this society of their own that needs to have some autonomy from the wider society. So that dependence on these social structures, what he's going to call the norms of science, was unspoken. Scientists just took it for granted. But then these threats happened around the world, and he said, now it's time to make this explicit so that we can defend it, this normative structure. So he says, the technical methods of science, he doesn't want to touch those. He thinks those are epistemically special. They're not influenced by social factors. They shouldn't be influenced by social factors. And that's what gives us knowledge, this empirically confirmed, logically consistent knowledge. And the goal of science is the extension of certified knowledge. Okay, this is the key point. So what's the function or the goal of science is to extend certified knowledge, which it does through these technical methods. Now, here's the key point. The institutional imperatives, what he calls norms, or what we could call values, derive from the goal in the methods of science. So the norms derive from the goal. In other words, if you want the extension of certified knowledge, that's the goal, then you must have a particular set of norms. You have to behave in a certain way. If we want to know what is, then we ought to act in certain ways. This is what Kant would call a hypothetical imperative. If you want X, then you've got to do Y. In this case, if you want certified knowledge, then you have to have certain values or norms built into your scientific practice. And those are the norms that were under threat in Soviet Russia and Nazi Germany that he wanted to articulate with this essay. And he did it through what we've now called this acronym, KUDOS. Um, but before I get to that, one or 2 points here. Look, what he's saying is science is special, epistemically special. It gives us a privileged access to truth and reality. But what makes it special are not the individual scientists. It's not the virtue of the scientists. And look, in the 18th, 19th, and even early 20th century, this is what was thought to be the source of the specialness of science, is that scientists themselves were these sort of superior, excellent human beings who possessed the moral virtues of character to undertake the noble enterprise of science, right? Now, Merton says that's not what's special about science. It's the institutional norms, not the individuals. You can almost plug any individual you want as long as you've got these institutional norms. You'll have high quality, high integrity science. I mean, agree with that or not, I just want you to be clear that's what he's saying. So there are these 4 norms, he says, comprise the ethos of science. If you violate these norms, you violated science. That is, you're not doing science, okay? You're not extending certified knowledge. So in other words, these norms are constitutive of science. They are essential, necessary for it. Here they are: kudos, the C, communism, shared ownership, and open sharing of knowledge. Go back to that vaccine and all the spying going on. Merton, I think, is rolling in his grave. This is not the way to do science. All the nations of the world should openly be sharing all of the data they've got on vaccines. It's crazy. More than that, it's a violation of the normative structure of science to have secretive research going on and then spies trying to get at it. Okay, that's what he's saying with this first norm. You're not doing science if you study something, you write down your findings, and then you stick it in a drawer and never share it. We have to learn from each other. Science is a social process of learning. You have to share. It's foundational, fundamental. If I've seen further than others, it's only because I stood on the shoulders of giants, Newton's quote. In other words, they shared what they knew so that I could start from there and not have to start from scratch. Okay. That's a norm. It's a value, right? Universalism. Truth, this means 2 things, really. Truth claims are subjected to pre-established impersonal criteria. You don't get to say, as was happening in Nazi Germany, that that's not true because he's a Jew. Totally anti-scientific, right? That destroys science, that sort of thing. And the other part of this, meritocracy. Careers are open to talents. You don't get to say, we can't advance her in the hierarchy of our laboratory because she's a woman. No, right? Off the table. That sort of thing takes you out of the realm of science. So this meritocratic value and this pre-established impersonal criteria value are necessary for science. Disinterestedness, okay. Now, this is when it gets tricky. Most of my students have trouble on this one. So let me just take a moment to say, look, he's not saying that scientists are disinterested, that scientists somehow don't care, right, what they find. They're like, oh, okay, I guess that didn't work. No, scientists, in fact, are super passionate and super interested in the sense that they really want to know, and they even really want their theory to be right, okay? So again, it's not that the scientists are somehow morally superior, that they can be above the human level of interest. No, they're very human. Disinterestedness really means peer review, basically. It means the institution has these mechanisms where every peer is looking over every other's shoulder and really trying to figure out, is that really what happened? What you say happened? Because they have an interest actually in making sure that you're right. One, they'd rather be right. But 2, if you are right, they're going to be building on what you did, so they want to make sure it's a solid foundation, right? So disinterestedness, as in not allowing wishful thinking to replace empirically based certified knowledge, that is a property of the institution collectively, of peer review. And it's not because scientists individually are disinterested. That's what he's saying there. So if you think this one's confusing, just think peer review. Peer review allows the community to control and quality check itself so that they're not allowing wishful thinking, political thinking, opinions to pass for what would be true knowledge. Okay, so that's really peer review. And the last one, organized skepticism. All beliefs are open to scrutiny. You don't get to say, well, the dear leader, the dear Führer doesn't want us to challenge that belief, so we're not going to touch it. No, everything has to be subject to these truth-probing modes of inquiry, right? I put a little subnote here, though. Something for us to think about in the future. So 6 subnote 1 here. Really? Right? Organized skepticism. But how far should we push skepticism, right? Because Newton said he stood on the shoulders of giants, meaning he took what they had to say, not on blind faith, say, but he didn't go and redo everything before him, right? He built on that. So he wasn't skeptical in some hyperactive way of challenging and questioning everything. So science builds up these certified knowledge claims. And it seems like at some point those controversies are closed, they're certified in his language, and then you don't have to be skeptical about those. So I think this organized skepticism is a really interesting balancing act, maybe. Okay, one warning and then we'll wrap up. I think this is a fascinating part of his essay, and I want you to think, for example, about QAnon and other things going on in our supposedly enlightened society. Conspiracy theory, disinformation. Merton says, you know, sometimes what scientists tell us seems so far-fetched it runs counter to common sense, like wave theory, quarks, atoms, right? We don't know. This stuff doesn't seem like it's really going on. That creates a situation in which pseudoscientific authority figures can borrow the authority of science, he says, for what they say. And so you can get all these quacks and mystics and captains of disinformation saying just a bunch of crap. But it has the patina of looking scientific. And look, the real science looks crazy enough to begin with. So how is the person in the street? What does he say? The man in the street. Okay, forgive his 20th century androcentrism here. The person in the street. How are they supposed to tell the difference between legitimate authoritative science and a pseudoscientific quack? Because they both sort of seem like, well, not common sense, right? So keep that in mind, because I think that's very telling about some of the situations we're in now in our hyper-mediated, hyper-information age. All right, we'll end with Akbar. A little backstory, you have to know Galen Erso. If you know anything about the Star Wars saga, this is the guy who built the Death Star. But he was a good guy because he's the one who planted that Achilles heel in it. So he's a scientist who was working on a bad project, the Death Star. It doesn't get any worse than that, right? But he decided, this was a really interesting ethical dilemma for him. He decided, rather than refuse to work on it, I'm actually going to work on it, but I'm secretly going to plant the seed of its own demise in it. And then I'm going to get that information out to the rebels so that they can destroy the Death Star. Really interesting moral dilemma. The way Akbar put it is Galen Erso put some good values in a bad science experiment, that is the Death Star. And I thought that was pretty wise of Akbar. So I wanted to share that with you. Okay, enough of me rambling. Until next time, may the force be with you.